Everyone. Today we are going to be looking at higher order derivatives, and higher order derivatives are exactly what it says. So you start with a function, you take the derivative once, and it is your first derivative. You take the derivative a second time, second, third, fourth, fifth, etc. The only thing that I am going to make sure that I point out right now is notice first has 1 tick mark, second has 2, third has 3, and then we start using numbers 4, 5, 6. So if we start off with just a little function here, my first derivative, f prime of x, is going to be just power me down. So the 6 comes down along with the 8, so I would get 48 x to the 5th, subtract 50 x to the 4th, and then I'm going to add 15x to the 2nd. First derivative. So now, if I take the derivative of that, power it down one more, it's second derivative. So 48 times the 5 coming down is 240 x to the 4th, subtract 200 x to the 3rd, plus 30 x to the first power. That's the second derivative. Okay, so now with the trig, so this is reviewing a little bit from yesterday. So the first derivative, what is the derivative of a secant? And hopefully you guys now have it known. It's a secant tangent. So there's my secant, there's my tangent. Now, for my second derivative, I have a first x, secant x. I have a second x, a tangent x. This would be a product rule. So, for my product rule for the second derivative, I still have to remember first derivative of second added on to second derivative of first. So that's the pattern that I'm going to follow. So for my second derivative here, I am going to color code it like I've done. First is secant x. Derivative of the second is secant squared x. Added on to the second is tangent of x. And the derivative of the first would be a secant or a tangent. What am I taking the derivative of? Derivative of secant is another secant tangent. Secant tangent. Sorry, I ran out of space. Okay, so putting it all together for that second derivative. Oh, it didn't switch colors. Oh well. It is secant cubed of x, and then it's going to be added on to a secant with a tangent squared of x. Now, I leave my answer like that. If you check the book solutions, they're going to factor out a secant and have this become secant squared plus tangent squared. That would be a book solution. And I'm okay with you leaving it just at the secant cubed. Okay, so we're almost done. That is primarily what a second or a higher order derivative is. So now it says I'm at the fourth derivative, find the sixth derivative. That means I have to find the fifth derivative, and that is just a power down for me. So that becomes 2. And then to find my sixth derivative, I have to, oops, I forgot my parentheses, would be 0. Done. Okay, so for this next one, it says, now look at all the pieces. The original function is 2, the derivative is -2, the original function is 1, the derivative is 4, and they want me to find f of 2. So they want me to find the first derivative plugging in 2. Here's my function. The original function here is my product rule. So what does the product rule? How would you take the derivative of it? My derivative would be the first times the derivative of the second, added on to the second, times the derivative of the first. Okay, so now it's just a matter of plugging in your numbers. This is a 2, this is a 2, this is a 2, this is a 2, this is a 2. Okay, so now g of 2, oh, that gets replaced with the number 3 times h prime of 2, oh, it gets replaced with a 4. Added on to h of 2, that gets replaced with a negative 1. And then g prime of 2 gets replaced with a negative 2. So now you've got 12 plus 2. My answer is 14. So this is just a way to double check to make sure that you understand what the product rule is. Okay, last side. This is where the most applications come in. And this is what you guys need to be able to do for explanations. The first derivative is the slope of the tangent line. That's velocity. So first derivative equals velocity. The second derivative is now going to be acceleration. So that is some new definitions that you guys need to know. So the original is going to be my position. The first is going to be my velocity. And the second is going to be acceleration. That's why we're learning higher order derivatives. So now you got to learn to read the problems. And in this problem, it says a car's velocity is this many feet per second. What's the acceleration at 5 seconds? What's the acceleration at 20 seconds? This is velocity. So in your head, you already need to know this is first derivative. It's asking for second derivative. So we've got to do what it says. Oh, look, it's a fraction. Guess what? My acceleration, which sometimes they write a of t, or if you want to write the first derivative of t, is a fraction. Guess what we get to sing today? Low d high minus high d low. Square the bottom and away we go. Again, blue's on the bottom, red is on the top. So here we go. My low is 2t plus 15. D high, derivative of the top, is just 100. Subtract the top, 100t, times the derivative of the bottom just turns out to be 2. Low d high minus high d low. Square the bottom, 2t plus 15 quantity squared, and away we go. Okay, so that's the calculus. Now, for the algebra, do your distributing. 200t plus 1500 minus 200t all over 2t plus 15 quantity squared. Okay, that's my formula now. Well, let's simplify it because do you see that the t's cancel? So my formula is 1500 divided by 2t plus 15 quantity squared. Okay, that's the formula. So let's mark this formula. And this would be for acceleration. Now, the question asked us find the acceleration at 5 seconds. So if I'm going to find it at 5 seconds, I'm just going to plug in 1500 over 2 times 5 plus 15 and square it. And when I do that, that's 1500 all over 10 plus 5 is 25 squared, which is 1500 over 625, which reduces down to 12 over 5. And this would be feet per second squared. Okay, so at 20 seconds, same idea, 1500 over 2 times 20 plus 15, and that whole thing is squared, which equals 1500 over, I grab my calculator, this is 3025, which turns out to be 60 over 121, and again that is feet per second squared. Okay, that's higher order derivatives. You're done.